This is 10.7, I think. 10.6 binomial theorem. All right, so really quick, we're just learning to use this binomial theorem. Our vocabulary we're going to learn is Pascal's triangle, and our objective is to use Pascal's triangle to expand powers of binomials and use the binomial theorem to expand powers of binomials. So those are our two objectives. So let's start with the beginning of what Pascal's triangle. So it's a man who discovered a pattern for determining the coefficients of the expanded binomial. So remember, we have a binomial a plus b raised to some power n. If it's square, it's pretty easy. We can use the full method. Beyond that, we have to do lots of distribution and multiplication, and when that's not too bad, but when you get past 3 it becomes pretty difficult. So Pascal discovered a formula or a pattern. So the pattern goes this: it goes in a triangle, because you look at the shape of the triangle, and each one's a row. So a plus b to the 0 power equals 1. Obviously anything to the 0 power is 1. Then a plus b to the first power is just a plus b. So the coefficient 1, 1. So there's ones along the very outside. Then a plus b, the second power, you start with your 1 and your 1 at the end, and you take the row above it and add them. So 1 plus 1 is 2. So the coefficient is 1 for the first term, 2 for the second term, and 1 for the third term. And we'll look at this closely. So let's look at a plus b cubed. So if I have a plus b times a plus b times a plus b. According to Pascal's triangle, it was 1, 2, 1. So this is to the 0 power first and second. And then we're going to do third power. So 1, 1. So we go 1 plus 2 is 3. 2 plus 1 is 3, and you add your 1s at the end. So this is to the third power. So you're going to have 4 terms, 1, 2, 3, 4, with these coefficients. So let's just do the full for this. So we get a squared plus 2ab plus b squared. Okay, I did this in my head, and we're not going to spend a lot of time. It's just using the FOIL method, first times first, outer, inner, less. Now I have these two times this. So I'm going to distribute this a. So I'm going to get a cubed plus 2a squared b plus ab squared. Then we're going to distribute the b, and we're going to get plus a squared b plus 2ab squared plus b cubed. Now we're going to combine like terms, and we get a squared plus 3a squared b plus 3ab squared plus b cubed. So I ended up with how many terms? If you look at it, I've got 1, 2, 3, 4. What are my coefficients? 1, 3, 3, 1. And you see Pascal's triangle. So this is to the raised to the 0 power, first power, second power, third power. And these are all a plus b raised to those powers. So you see my coefficients. So we can continue with this pattern. So look at the next row, a plus b, the fourth power. So we put our 1s on the outside. We go to the previous row. 1 plus 3 is 4. 3 plus 3 is 6. And 3 plus 1 is 4. We come down to do the next row. We do 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then we add the 1s at the end. And those are the coefficients. Pretty simple. So let's use Pascal's triangle. So basically they're telling us to use Pascal's triangle. They give us a word problem. It says, find the probability of hiring 6 men and 2 women by expanding the formula m plus f to the 8th power. So we've already got what Pascal's triangle is to the 5th. So we just add 3 more rows. 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, you add the 2 1s. So that's to the 6th power. Go down to the next row, which would be to the 7th power, and you're going to go 1 plus 6 is 7, 6 plus 5 is 21, 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21, and so on, and you add the ones, then you get to the final one, you do the same thing, you end it with these coefficients. So then we go back and we put them into the coefficients. So I'm going to give you the pattern for the a plus b. So this would represent a and b, or m plus f. So it's to the 8th power, so the first one is going to be m to the 8th. The next one is going to be m to the, you go down 1 power, 7th, but then you have to do f to the 1st power. So these two powers have to equal your power of your binomial. Then you do m to the 6th, so f is going to be square, because 6 plus 2 is 8. Then m to the 5th, so f has to be 3. M to the 4th, so f has to be 4th. M to the 3rd, f has to be 5. M to the 2nd, f has to be 6. M to the 1st, f has to be 7. And then f to the 8th. Technically, you have m to the 0, so that's why you don't put it, because anything 0 power is 1. Then you just add the coefficients. That's the first term. So you're always going to have one more term than the power. So I've got 9 terms here. So coefficient 1, 8, 28, 56, 70, 56, 28, 8, 1. So by adding the coefficients of all this polynomial, we determined that there were 256 combinations of males and females that could be hired. 28m to the 6f2 represents the 6 males and 2 females, and you take the probability of 28 out of 256, or about 11% chance of hiring males. So I'm not really worried about doing probabilities. I'm worried about you knowing how to do Pascal's triangle and the process. All right. Now we're going to look at the binomial theorem instead of writing out the rows of the Pascal triangle, because this could get pretty tedious if I did. I mean, I could do it if I wanted to do a plus b to the 15th power. It would take me a long time. So instead, we can use the binomial theorem to expand. So if we recall, for probability, we have C in R equals n factorial over R factorial times n minus R factorial. All right, so we're going to use this. Let's see if this moves for me. So this is the key concept binomial theorem that you need to know. So if n is a natural number, then a plus b to the n is going to equal to this probability, this combination, C n comma 0. So n is always going to start with what power it's raised to, and this is the very first one, so it's going to be 0. Then it's a times nb0, just like we did before, plus c, and then becomes n1, the second term, and this is a to the n minus 1, b to the 1. So this number right here, the r, is going to represent whatever the power of a is. Okay, so technically, when you're putting this into your calculator in a probability, n is going to be the power of the binomial, and then r is going to be, if you wanted the coefficient of the 5th term, it would be 5 minus 1 is your r. So that would, what would go there would be 4. So basically it's the sum. You can write it as a sum, sigma, which k is equal to 0 and n is your power of your binomial, which becomes n factorial over k factorial over n minus k factorial times a to the n minus k and b to the k. So what does that mean? So if I have a plus b to the 7th, so let's write it out. A plus b to the 7th. And they want us to find the, replace n with 7 in the binomial theorem. Okay, so we're using this formula here. Let's see if it'll go. Computer's not cooperating. Into this formula here. Okay, so n is going to be 7 for all these, and the first one's going to be 0, and then 1, 2, 3, 4, 5, 6, until you get to 7. All right, then the coefficients, remember it's a to the 7th, a to the 6b to the first, a to the fifth, b squared. So what we're saying is this is our formula. So we know that if I want the coefficient for the first term, it's going to be C7, 0 is my coefficient. That's what I put in. Instead of using Pascal's triangle, this is the first term. Times a to the 7th plus c to the what? It's still 7, and this is 1, and it's a to the 6, b to the 1. Maybe if I put parentheses, it'll help you realize. So remember, these are the coefficients. We use Pascal's triangle, but instead of writing it all out, if I just wanted the fifth term of this binomial expanded, then I would go C7, 5 minus 1 is 4, and then a would be to the fourth, so b would have to be the third, because remember, these two powers have to equal this. And if you put that in your calculator, you're going to hit the math button. Then you're going to scroll over to probability. And then you're going to hit the number 3. And then you'll get this C with 2 boxes. You're going to put in 7th. If I wanted the fifth term, that would be 5 minus 1. So you would hit 7, 4, and then my coefficient would be, so the fifth term would be 35, a to the 4th, b cubed. Okay, so right now we're doing binomials that both have a coefficient of 1. So let's continue this. Okay, so if you look at the 7th row, and the 1, 2, 3, 4th term is 35, and that's what we got for the 5th term. They both have a coefficient of 35. All right, so they want us to expand this. So this is when we have coefficients that aren't 1. So let's write this out. So it's 5a minus 4b to the 4th power. Okay, so we'll start with doing, okay, remember now, this whole thing is a in the formula, a plus b to the n power. Just like, why is this? So we said it's 5a to the 4th power okay, plus we said 5a to the 3rd power times negative 4b to the 1st power plus, I have to come down here, 5a to the 2nd power times negative 4b to the 2nd power plus 5a to the 1st power times negative 4b to the 3rd power plus negative 4b to the 4th power, because the 0 power is just 1. So those are our a's and b's. Now we still need to find our coefficients. Okay, there's 1, 2, 3, 4. Remember, we have one more term that on power. So to find our coefficients, it's C, N, R. So this first one is going to be C, 4, 0. And we put those into our calculator. So remember, this is 5a to the 4th power. So it's 5 to the 4th power, which is 625. So that first term is going to be 625 a to the 4th times, when I put this in there, I'm going to hit math, probability, then I'm going to hit the number 3, and I'm going to type in 4, and then 0, and I get 1. So 1 times that is just 625. And then this one is going to be C4, 1. So I hit math, probability, 3, 4, and 1, and I get 4 times 5 cubed. Okay, so remember this is 5a cubed, so you distribute using the power rule. So that's 125 times 4, so we get plus 500 a cubed. Oh, I forgot about times negative 4 and b, so 500 times 4 is 2,000. So this is actually negative 2,000 because you're multiplying all this together. This 5 cubed times negative 4 times, and we said this was 4. And you get the picture. So here, negative 4 squared is going to be 16b squared times 25a squared. And then this one's a third term, so it's going to be c4 2. So math, probability, 3, 4, 2, which I believe is 6. So 6 times 25. So this coefficient is going to be plus 900 a squared b squared. So remember, these powers have to equal this. And they just keep changing. The a descends and the b ascends. And you continue until you've done all. We have 1, 2, 3, so we have 2 more to go. And that's how you expand using the binomial theorem. And you see they've got that here so far. Minus 2,000, plus 2,400, and so on and so on. Okay, so sometimes you might need to find only one term. So again, if they want us to find, let's look at this one here, y plus z to the 13th. So we have y plus z to the 13th, and they want us to find the fifth term. So we know the coefficient is going to be C13. They want the fifth, so the fifth is going to be 5 minus 1 is 4, and then times y to the 4th power, remember this has the same, times z to the 9th, because these two have to equal 13. And then you put this in your calculator since they both have a coefficient of 1. And you get math, probability, 3, 13, and 4, and you get this. The fifth term is 715 y to the 4th, z to the 9th. You just have to know this formula, C in R, and n is the power of the binomial, okay, and R is going to be the term, example, fifth, minus 1. And then you multiply it by a to the r times b to the n minus r. And they call it k. But this is basically your formula right here. And that's all you need to know. All right, do the homework problems, and we'll see you in class.